CNC machining is not like 3D printing, which has a lot of just click print features. But every CNC machine follows these same relatively simple steps. Load your file, position your material, zero your tooling, and then cut out your project. And the Altmill is no different, but like any CNC machine, it does it all in its own unique way. Today I'm going to be showing you an overview of how to cut out a project on the Altmill so that you have a better understanding on how it works. CNC Labs sent me one of their brand new gControl panel computers to use with the Altmill. And now that I have it in the shop, I can show you the entire process from start to finish using their own purpose-built ecosystem. So let's start by turning it on. I have all of the electronics for my Altmill on a single surge protector. The setup that you see here requires a total of 3 plugs. One for the spindle, one for the super longboard controller, which I leave on the on position all the time, and then the last for the gControl panel computer, which I also leave on the on position. But if you have a water-cooled spindle or additional accessories, you might need some more plugs. After powering on all the devices from the surge protector, you're going to need to do 2 things. Turn on the gControl by pressing a small silver button at the bottom of the unit. This will boot up the computer, which was much faster than I anticipated. Next, while that's booting up, depress the e-stop switch and then cycle it. This is a safety measure that you're required to do every single time that you start the machine. Next, you're going to boot up gCenter on your gControl panel. For some reason, I was not able to force it to open up upon startup of the computer, so if anybody knows how to do that, it will be highly appreciated. Let me know down in the comments down below. At this point, you can connect to your machine, that machine being the Altmill. I currently have it set up to connect by USB-C because I wasn't able to get the Ethernet connection to work as intended. I assume it's a very simple fix, but I haven't actually reached out to anybody at CNC Labs yet, and the USB-C worked perfectly fine, so that's what I'm sticking with for right now. After connecting to the machine, you click the Unlock Machine, and then you can initiate the homing process. Out of the box, this is going to bring your spindle to the back left corner of the machine. And once it's made it to the corner, it will wait there until it's given its next command. Speaking of command, this is when we're going to be loading in our file. The nice part about gControl is that it is a computer capable of hooking up to the internet and even running programs on it. So you could run Carveco or Vectric or even check your email. It's a computer that's just hooked up to your CNC machine. This means there are a few different ways that you can send your G-code to gSender. You can do this all over network, you can email it to yourself, you can directly create the file on your panel and save it, or you can load it like me over a USB drive. At the bottom left-hand corner of gSender, you press Load File, find your G-code, and then load it. Once you do this, you'll see a rendering of the cuts that you're about to make in a nice little blue pattern. That will turn gray once you're actually cutting. Now that your file is loaded, you can get to securing your material on the CNC machine. I'm using double-sided tape on this 1-inch thick walnut. You'll see a little bit later that I decided to also use brad nails after it started cutting due to a slight shifting in the material because it was a little bit bowed. This specific project doesn't require things to be ultra precise, so I just visually lined up the material with the holes and slot on my wasteboard and stuck it down. This modular dog hold wasteboard was last week's project, so check it out if you're looking for a simple way to set up and swap your wasteboard. After that, I jogged the spindle over to the material using the gControl computer so that I could start the zeroing process. After getting the X and Y positions located at the bottom left of my material, I change the movement speed to precise and I start to probe for my Z height. Now this is the manual way to do this process, but if you have a probe, you can get even more accurate results using less steps. But this is how I zero my machines and it doesn't require any additional accessories, so that's why I'm showing it this way. I use a piece of yellow paper for my double-sided tape and moving it around as I slowly lower the bit. Once there's slight resistance to the paper, I know that I'm ready to zero everything out, the X, the Y, and the Z. After zeroing, you can jog the machine to any location and it will remember where the material is at and how you want to cut it based on the file that you've loaded onto the machine. I'm using one of the quick buttons to send the machine to the back right position, but no matter where you move it, you can press go to XY0 and it will turn to the XY0 position. Then you can press go to next to the Z0 and it will return to where you would zero the Z axis. You do not have to return to any of your zeros to start the program. I'm just doing this to show you that you can. Normally, after zeroing the machine, I would raise the Z-axis all the way and put on my dust boot and make any other tweaks before starting the program. But I'm not using dust collection just for video purposes, but you should definitely use dust collection as much as possible to reduce how often you need to do maintenance on your machine. At this point, you can change the views of your project if you're interested in how many more cuts there's going to take in certain areas. The screen holds a lot of helpful information for your projects and will give you a ton to look at while your machine's running, or you could just stand there and watch it run like everybody else. And now we're officially ready to start our job. Here I'm showing you that at any point while the machine is running, you can pause job, This will stop the machine, but the spindle will still remain at its job speed. So if you want to stop the spindle, you'll need to do that separately. This is helpful for a myriad of reasons, including getting a better camera angle. So simply press resume job and it will immediately start moving again. You can see here that my material is dancing around due to some bowing in the walnut that I'm using, so my double-sided tape is obviously not sufficient. But that's a simple fix. I pause the job and I put in some brad nails and then I resume the job. We're cutting out a project that I've had on the list for almost a year now. I'm calling them my wall pocket hooks. They're to hold simple items like dog leashes or kids' backpack without showing any screws, almost like it's floating on the wall. It requires a single bit, the downtown Jenny, but you can make this with any down shear 1/4 inch bit. The project heavily relies on mortise and tenon designs. The tenon, or the male part, gets small pockets that are meant to snugly hold magnets, while the female, or the mortise part, gets small indentations where the screws are going to go in. All of these shapes and pockets are perfectly lined up, which means a dependable end product. Once the tenon enters the mortise, the magnets grab onto the screw head and creates a secure bond that is reinforced by tight tolerances of the mortise and tenon joinery. This will give us a really clean final product. My feeds and speeds are very reserved, and it's taking around 20 minutes to cut out these wall pocket hooks. If I were in full production of these, I could easily get them down to under 2 minutes each, but most of the time I stick with the feeds and speeds on CNC with me. This helps show an accurate project time that almost any CNC can achieve without worrying about breaking bits. The Carveco and vector files alongside a toolpath tutorial for this project are now available on cncwithme.com. After everything was cut out, I came back with my dust collection and cleaned up the area as well as any dust that had gotten onto machine components. I then popped up all of my parts and you can really see how accurate the Altmill is. It perfectly cut out the parts and barely kissed the double-sided tape, just like I had programmed it to. There are very few things that are more satisfying than this, and I absolutely love it when a plan comes together. Now that all the parts are all free, I can come back and do some sanding. The down shear of the downtown Jenny bit leaves some strings on the bottom side of the hardwood. An easy way to eliminate this on your projects for profile cuts is to switch over to a compression bit, like the original Jenny bit. Compression bits are great for profiling, but I don't like them very much for pocketing, which is why I always default to the downtown Jenny. I used a drill bit to create the screw holes. If you want to get fancy with this project, you can switch over to a V-bit and create the pilot for the screw locations, but that seemed to be more work than just taking a drill to it afterwards, but each to their own. If you want to do it, definitely go for it. I also ran a small roundover on the face of the profiles to soften the edges a bit, and I think it turned out really nice. With all that taken care of and making sure that the parts fit correctly, I can put in the magnets. I grabbed a few and made sure that they were facing the same direction by having them all stuck to a screw as I mounted them. I grabbed a section of T-track because it was very flat, and I pounded them into place with a mallet. No CA glue necessary. The fit is just right, and it leaves the magnets flush with the surface of the wood, making them very easy to hold onto the screw heads once the part is in place. I then put a few coats of aerosol lacquer, making sure to lightly sand them with 320 grit sandpaper between each coat. This is a really easy and quick way that I've been using to finish my small parts. But it does take a day or two for them to fully off-gas and stop smelling like lacquer, but I think it's completely worth it. After that, it's as simple as screwing them to the wall. This design leans towards mounting them directly onto a stud due to them being staggered the way that they are, but I'm sure that you could still get great results using drywall anchors as well. I don't have a dog, and I didn't think it was financially responsible to go and purchase a $20 dog leash just to show it in action for 2 seconds. So here's me with a bundle of tree cutting rope that looks similar to a dog leash and pretending that it's a dog leash. The process of using an Altmill is very straightforward. The combination of the gControl panel and G-Sender makes it a very fluid process that's very easy to understand. If you're interested in getting an Altmill or upgrading to gControl panel computer, check out the links down below this video. Using those is a great way to be able to support the channel without any additional cost to you. Now that the gControl panel is here, I have started my testing for my Altmill vs. Winfinity video. That video will be released on Black Friday. I've been getting a ton of y'all reaching out wanting to know my opinions on the two machines, and I'm really excited to release my comprehensive video and thoughts between the two different machines. If you're interested in that video, please subscribe and turn on notifications. And if you like this video, please take a moment to like it. It shows YouTube that it's worth watching and worth showing to other people. None of this would be possible without all of you CNC With Me members. And if you haven't seen, there's a brand new survey over on cncwithme.com about some upcoming changes for 2025 that I'm very excited about. If you haven't had a chance, please fill that out. I would love to know your thoughts. As always, thank you so much for taking the time to watch this video. I hope that you got something from it, and I will see you next Friday. Bye.